So there was an intro video that started the digestive tract. So if you haven't watched it, make sure you watch it. Again, most of the digestive tract, we're kind of going in order top down. So the intro video goes over a lot of stuff in the mouth, including your teeth, your taste buds, some of your salivary glands. It also goes over the 4 basic layers found in the digestive tract that go all the way down. Today, we'll see how far we get. In Part B, we're working our way down the digestive tract, so just beyond the mouth. We can get it to go. We have the pharynx. So once food leaves the mouth, it goes into the pharynx. And the pharynx is divided into 3 regions: nasopharynx, oropharynx, and laryngopharynx. Well, food is only going to go into the oropharynx and the laryngopharynx because we don't want it going up into the nasopharynx. We want food to go downward, not up into our nose. And it's just a passageway. Now, note about the pharynx. The pharynx is part of the respiratory tract and is part of the digestive tract. And so we will have to eventually divide there. We'll have an epiglottis that switches back and forth for moving air and food. The lining of the pharynx is stratified squamous epithelium. It's there so if you didn't chew your food all the way, you ate a Dorito and you just didn't chew it all the way and you swallowed it and you could feel it just scraping all the way down. Well, our pharynx is lined with stratified squamous epithelium, so we can lose a few layers of cells there and we're not going to do any serious damage. It does have a lot of mucus-producing glands, so again, if you didn't chew your food very well, that mucus kind of helps aid the passage of that food down. At the top, it does have skeletal muscles. Now, we generally do have control over skeletal muscles, and that's because part of the pharynx is part of the swallowing process, which we'll go over, and that's the part that's skeletal muscle. Later on, as we go down the digestive tract, we get into smooth muscle, which you don't have any control over. And there are also some pharyngeal constrictors found there as well that pretty much have it so we have a one-way direction of food through the intestinal tract. So could you, in theory, be hanging upside down and eat something and it make it all the way through your digestive tract? You could, and probably won't be super comfortable, but you could. We have constrictors all along the way so that you eat food, swallow it, and it's a one-direction way, even if you're upside down. Now, after it leaves the pharynx, it goes into the esophagus. The esophagus itself is a flat muscular tube. The only time it's not flat is if you have food or beverage in it. It's about 10 inches long. And I'm like that you can see the esophagus. It goes from the laryngopharynx region. It goes through the diaphragm, because you do have that big, huge muscle that goes all the way across. Well, there's a hole in the muscle. That hole in the diaphragm is called the esophageal hiatus. It's almost just like a little break for the esophagus. And the esophagus will lead all the way down to the stomach. The hole in the stomach where the esophagus meets is known as the cardial orifice. And right there, we have what's known as the cardiac or the gastroesophageal sphincter. Just means where the stomach and the esophagus meet, there's another sphincter right there at the stomach. Now, some things can happen with that cardiac or gastroesophageal sphincter is that if it's not working correctly, because it should stay closed until, I almost like the other picture. This should stay closed until you are swallowing food and we want food to go into the stomach. Otherwise, that cardiac sphincter always stays closed. However, it can happen that some of the acid and some of the stomach juices that are in here can, get above that sphincter, and now you have acid getting up into your esophagus. Your esophagus isn't meant to withstand large quantities of acid. It will start to hurt. It will start to break down, destroy your esophagus, and we call it heartburn. Now, main reason why we call it heartburn is because that cardiac sphincter, if you're looking at it, the stomach is kind of lying right underneath the liver there. The cardiac sphincter at the top part, but near the top part of the stomach is sitting about here. And when this happens, if you have acid going into your esophagus, you're going to have pain right here. And what's sitting right about here? That's your heart. And you're all of a sudden like, oh, I have so much pain right here. What do most people think they're experiencing? A heart attack. There's lots of people that go to the hospital because they honestly think they're having a heart attack. And that doesn't mean that if you actually think you're having a heart attack and you're like, no, I'm sure it's just heartburn. I mean, if you think you're having a heart attack, go to the doctor. But a lot of times it's just heartburn. Mm-hmm. Yeah. Just in the pain, and it goes away. And that it's just the pain from the acid. So I'm like, it happens, and I'm like, again, go to the doctor. But things that can cause you or put you at an increased risk of having heartburn, that cardiac sphincter not working. Well, if you eat or drink a lot, if that stomach is really full, like after that Thanksgiving or Christmas meal and your stomach is so full, it's likely that sphincter can't hold everything in there and stuff can go backward. Extreme obesity can cause that muscle just to be slack and not as strong. Pregnancy, because now you have that whole baby that's in there that's pushing up on the stomach. There's extra force there. And running, and I'm like that sloshing around of whatever's in the stomach can cause that to happen. Now, another thing that can happen with that sphincter is that it does happen that there are times that part of the stomach, that's what this is really showing, part of the stomach itself is above the diaphragm. That's the diaphragm right there that cuts right across your entire abdomen. And I'm like, the whole stomach should be sitting below the diaphragm. It happens sometimes that part of that stomach goes through that little hiatus, that little break in the stomach, and ends up on top of the diaphragm. Well, that means every time your diaphragm is contracting, it's like squeezing on this, which can also cause more of the stomach juices to go up into the esophagus. Damage to your esophagus can be permanent damage. I mean, it's going to be painful. People that have long-term heartburn, it's undiagnosed, untreated. It could cause ulcers. It could cause esophagitis, that's inflammation. And it could cause esophageal cancer. That non-stop damage to those cells, sometimes they can't fix themselves without having some type of mutation leading to cancer. So I'm like, it can cause bad side effects. Usually it's pain. Now, in the esophagus, so it's a big old tube, and it still has the same 4 layers that the whole digestive tract. Some of the kind of unique things about each of the layers. One, the mucosa layer, the inside layer, also has stratified squamous epithelium. So again, if you didn't chew very well and you scrape a few layers, it's okay, it's not super bad. But so this is the stratified squamous epithelium. But as soon as that esophagus hits the stomach, it changes, like abruptly. It goes immediately from stratified squamous epithelium to stomach, which will become the simple columnar. And I'm like, it's a very much one right to the next. But I'm like, but in the esophagus, stratified squamous. We also have glands in there that secrete mucus, also to help aid in digestion if you didn't chew well. We have a skeletal muscle still near the top of the esophagus, but then as it gets to the bottom esophagus, it's all smooth muscle. And I'm like, and it's just going to contract to move the food top down. And then the outside lining is a fibrous adventitia. And I'm like, it's a fibrous layer on the very outside. It's almost a little more protective as it's sitting inside of just like your cavity inside your body. Now, I was going to say, because the intro video does go through different parts of the mouth, but it doesn't really go through processes. So all together, we've gone over the mouth in the intro. And I'm like, and our pharynx and our esophagus, but processes is, we've got the parts there, but what are things happening actually in the mouth? What are things that are actually happening in the pharynx and the esophagus? Most of the processes for digestion happen in the mouth. Lots of things happen in the mouth. Lots of food breakdown happens in the mouth. So in the mouth, we have ingestion, means you're bringing food in. It's got the word in it. We have mechanical digestion. That's the physical breaking down of food. As you move stuff around in your mouth, you are physically breaking it down with your tongue as you smush it and your teeth as you're, clipping it and grinding it. We have what's known as propulsion, meaning we're moving food along the digestive tract, and that's going to be with swallowing. The official term for swallowing is deglutition. We also start having some chemical breakdown. It's It's not a lot of chemical breakdown, but we have a little bit of chemical breakdown because we do have some enzymes in our saliva. We have a salivary amylase, which starts to break down carbohydrates. So food is starting to get broken down even in your mouth. And I'm like, chemically wise, there's a little bit of chemical breakdown. We have lingual lipases, enzymes, endinase. This breaks down lipids, also coming from the mouth. And I'm like, lingual means tongues. It's coming from the tongue. But my note on there, really, we don't have any food absorption. The mouth's job is to break down food. I mean, most of it is mechanical digestion with chewing and smushing around with your tongue. And I'm like, some chemical breakdown, but we don't have any absorption taking place yet. And most of our chemical digestion happens later, and all of our absorption happens later. Now, one of the big things that happens inside your mouth for mechanical digestion is chewing, officially known as mastication. And I'm like, so you've got your cheeks, you've got your teeth, everything is holding the food inside of the teeth area. Most of you aren't trying to chew your food when it's out inside your cheek. You want it really inside the teeth. And I'm like, the tongue mixes that food around, whether you realize you're doing this or not when you're eating. The tongue is mixing that food with the saliva that's in the mouth, and it compacts the food into what's known as a bolus. It means a food ball, ultimately, but it's a chewed up food ball. And so when you swallow your food, it's now this, what they call it, a bolus. It's a chewed up food ball. Your teeth help cut and grind it. Part of chewing is voluntary, which means you do have control over it. You could be like, okay, I'm going to chew slow, and you can control your chewing, but it's also partly reflexive. You put food in and you just start chewing. And I'm like, you don't even have to think about it. You could be doing other stuff and you're just chewing away without thinking of it. So it's partly voluntary, you've got control over it, but it's also partly reflexive as well. Now, after you chew it, you do have to swallow it. That's the deglutition, that's moving the food along. It involves the tongue, it involves the soft palate in the top of your mouth, it involves the pharynx, and it involves down to the esophagus as well. And it happens in two phases. The buccal phase really is the phase, that your mouth is contributing to it, and it's voluntary, meaning you do have control over this. Even if you're not thinking about it, you could think about it and control it. Once it gets into the pharynx and down into the esophagus, it enters the pharyngeal esophageal phase. You don't have any control over that food anymore. So I'm like, it's the part of the swallowing you have no control over. It's all involuntary. Now, the various phases, I break it down so you can actually see this. The very first part about the buccal phase, so it's in your mouth. There's your little food ball. You've been chewing it for a while, and you've got your food ball in there. And I'm like, up by your glottis, and I'm like, we're going to actually have that esophageal sphincter closed. We're trying to keep food up there. All we're doing in this first phase is just trying to get all of that food near the top of your mouth and near the back of the mouth. So your tongue is kind of smushing it up, moving it towards the back. Then it's going to enter, it doesn't hang out in the buccal phase long, into the pharyngeal esophageal phase. Now, a couple things happen in the pharyngeal esophageal phase. One is the uvula, a little dangly thing at the back, will move backwards to block off the nasopharynx. Why is that helpful? What's it going to prevent? Food from going up, so that when you swallow, food doesn't go up into your nasal cavity, and it goes downward, which is why, again, you could eat upside down. So the uvula is going to go out upward and block the nasopharynx, and then the esophageal sphincter is going to relax, so that we are now getting food down into the pharynx and into the esophagus. Then once we've swallowed it and it's gotten into the esophageal sphincter closes, again, so that food doesn't go backwards. And at this point, we just have the muscle itself is squeezing the food down. Which is showing a mic. And it's eventually squeezing it down until it enters into the stomach. Once it gets to the bottom of the stomach, yes, that cardiac sphincter has to open so that the food can get into the stomach. Something else I was going to... Oh, my notice about, I was going to say, the trachea and the esophagus. They do line right next to each other. And it's one of those, the trachea is held open And I'm like, with cartilage. It's held open so that you always have a constant airway. The esophagus is always flattened unless you have food in it. So then I usually have the question, well then, I mean, they're two different tubes. How can choking, like how do you swallow something and then choke? Well, the back of the trachea is not held open by cartilage. It's soft at the back of the trachea. And that's right where the esophagus is. So if you swallow something very large and obstructive and you can't move it along, and I'm like, it will bulge that esophagus all the way into that trachea area, and I'm like, that you can't get any air in you anymore. And so I'm like, there's a reason why the esophagus is soft, is so that it does give some room for that esophagus to expand into it. And I'm like, but we also run into problems with choking. And I'm like, if food gets stuck there, and now you've blocked the airway because so much of it gets stuck there. Now, once food gets into the stomach, we divide the stomach into 4 regions. It hangs in the upper left-hand quadrant of your abdominal cavity. We have 4 regions. The cardiac region is just a tiny little area where you've got the cardiac sphincter. That's it. It's just where the cardiac sphincter is. The fundus is the top little bulge that goes upwards. The body is really the majority of the stomach. Generally, the body of anything is the larger part of something. And then this last kind of triangular region is known as the pyloric region. And at the end of the pyloric region, you have another sphincter or another valve. So you've got valves that can open and close at the top, and you have valves or sphincters that can open and close at the end. And I'm like, because we'll talk about that particular pyloric sphincter, because it's right after the pyloric region. Now, it's shaped, it looks kind of like a big, I don't know, kidney bean, jelly bean. The outside of it, I'm like, there's a curve. There's an outside curve and there's an inside curve. The outside curve is called the greater curvature. This is on the next slide, but I've got a picture on this one. The outer, bigger part is called the greater curvature. The tiny inward part is called the lesser curvature. And we have things hanging from those 2 curves. So the outer, greater, lesser, smaller. We have mesenteries. We have tissue hanging from the greater and lesser curvature. Now, their tissues are called mesenteries, and they're there to really anchor the stomach in place. So that when you run around, your stomach's not just flying all around inside of there, it's anchored in place. The lesser omentum that hangs from the lesser curvature, so you have tissue hanging from the lesser curvature, anchors it up and attaches to the liver. Where's my picture? So there's the lesser curvature. It's anchoring it right into place, right underneath the liver right there. So you've got one mesentery there. You also have what's known as the greater omentum that hangs from the greater curvature. They've cut it off so you can see underneath it. But it looks like a big, huge fat deposit. Sometimes it's even called a fat apron because that fat deposit covers all your intestinal area. I was going to say, I'm like, it's such a delicate tissue of fat, that greater omentum, that just from handling our cadaver, it's completely shredded. They've just removed it just because it's delicate and it falls apart in shreds. And I'm like, but it's a fat tissue that hangs right off the greater curvature. So you've got a lesser omentum hanging from the lesser curvature, a greater omentum hanging from the greater curvature, and you also have other mesenteries that are found all around your intestinal tract as well. It again is a fatty tissue, but you can see the mesenteries around the intestinal tract also have lots of blood vessels and lymphatic vessels flowing. Those mesenteries really are to help anchor everything in place. So you don't have lots of moving around of your intestines in your abdominal cavity. It's the only thing that really anchors them in place. Oops. Did I go too far? Now, the muscle, still, it's part of the digestive tract, so it still has 4 basic layers to it. The only 2 that have some uniqueness to it, one is the muscularis muscle is a little different and the mucosa layer is a little different. Everywhere along the intestinal tract, the muscularis muscle, or the muscle tissue found in your digestive tract, has 2 layers. It has a longitudinal layer and a circular layer. However, in the stomach, it has a 3rd. It has an extra layer of muscle, and it's an oblique layer. It goes at an angle. And that oblique layer, that extra 3rd layer of muscle in your stomach, allows the muscle to be squeezing at lots of different angles so that your food is churning around in your stomach. We don't need that anywhere else. The mucosal lining of the stomach also has to be very different because it's very acidic inside the stomach. So the mucosal layer has had to figure out how to adjust to that. And so the cells that are found in there, and it's simple columnar, meaning single layer of cells, and they're columnar, they look like they're tall columns. And the cells that are in there secrete a 2-layer coat of alkaline mucus. Again, stomach acid is very acidic. And so the mucosal lining has to be able to withstand that, and it does that by secreting an alkaline mucus so that that acid is neutralized. If it tries to get past that mucosal lining, and I'm like, it's neutralized in that alkaline mucosa fluid that's on there. Now, also in the stomach, we have little gastric pits, which they're seeing what the pits looks like. You almost have like little tiny holes all over your stomach itself. And it's because there are lots of cells that secrete lots of different types of secretions, which all together is, we just call it your gastric or stomach juice. That's what they call it, is your stomach juice. And I'm like, that you have lots of different cells secreting lots of different secretions, all to help somehow in making that stomach fluid and breaking down food. Now, there are 4. I'm just going to preview them. We'll talk about them on Tuesday. There are 4 cells, and so we do have 4 colors. We've got a pink, we've got a blue, we've got a purple, and we've got a green. They all do something. You're going to have to know what they do. And I'm like, only one of them is needed for survival, though. And I'm like, people can live without their stomach, but they have to replace one of the things that these things make. So I'm like, they all help aid in digestion, so, and somehow, but only one is actually truly needed for survival on why you need the stomach. Now, the one I don't talk anymore about except this particular slide are the mucous neck cells. And I'm like, that down in these gastric pits, these particular cells down here actually make a slightly acidic mucus. But we don't know why. It's like, we know that there's other acid made elsewhere, and we know what that acid does, but the particular secretion that these particular cells make, we're not exactly sure if they have their own specific function. So we know they make a very thin acidic mucus, but we don't know what it does. So on Tuesday, we're going to start talking about the parietal cells, the chief cells, and the enteroendocrine cells. And we'll start getting down to the chemical digestion and breakdown of food.